Today we're going to look at subtracting integers and modeling that with counters again. So just to warn you that sometimes you can get a little frustrated at first when you're subtracting using the counter. Your first instinct is to run directly to the rule that several of you know, or at least think you know, but keep an open mind. Look at the modeling first because I want you to understand why the rule is the way it is before we run to that shortcut rule. So we're going to start with number 1. So number 1 is a positive 3. So we're going to start with a positive 3, and the problem is asking you to subtract 5 positive values. So again, just to review what we did yesterday, that when we were looking at using counters, a white counter is equal to a positive number, and a red counter is equal to a negative number. And then also we're going to need to use the zero pair today that we talked about yesterday. So if you put a positive counter with a negative counter, remember that a positive 1 and a negative 1 have a value of 0. And this is called a zero pair. So as we look at number 1, it asks you to start with a positive 3. So if I start with a positive 3, I'm going to write down 3 positive counters. It wants you to subtract 5 positives, but I only have 3 positives that I can subtract. I don't have 5 positives, so somehow I have 3, somehow I have to get 2 more positives so I can take away 5 positive numbers. The only way to get 2 more positive numbers is to add the zero pair here. Remember that zero pair has a value of 0. So if I add a zero pair here, I'm really adding 0 to this value of 3. It looks like I've got a white counter and a red counter. So it looks like I totally changed the problem. But right here, remember, this has a value of 0 plus 1, 2, 3. So all of these together still have this value right here of 3. But now notice that when I added just 1 zero pair, I now have 4 positive counters that I could take away. However, I still need to take 5 away. I only have 4. So I've got to get 1 more white counter in there to represent another positive number. And to do that, I'm going to add a zero pair again. So I'm going to add another zero pair. So every time that you need a white or a red counter so that you can take away what you need to take away, add enough zero pairs until you get what you need. So notice here that we need to take away 5 positive numbers. I did not add 5 zero pairs. I just added 2 because I only needed 2 more so that I could take away 5 positives. Now look, I have 5 positive numbers that I can take away. So I'm going to remove 1, 2, 3, 4, 5. So I just performed this operation right here of taking away 5 positives. And look at what you have left. 1, 2 negatives. So your answer is -2. And if you think about it, if you have $3 in your pocket and you go to buy your lunch and the lunch lady is going to charge you $5 for your meal, but you only have $3 in your pocket. You don't have enough money in your pocket to cover that $5. So you're going to have to borrow enough money to pay for that $5 lunch. So you're borrowing $2. So you paid the $3, but now you're in debt to your friend for $2. So when you borrowed that $2, you're really borrowing a zero pair so that you could pay your $5. And now you've switched over to, instead of having $3, now you owe somebody $2 because you bought more than you could afford. Number 2, this time we're going to start with a -1 counter, which is a red counter. So you're starting with a negative counter. And the problem is asking you to take away 4 positives. I don't have any positives to take away. So I've got to get 4 positives here so I can take them away. The only way to get counters that you're missing, positives or negatives, is to add a 0 pair up to however many you need. Well, I need 4 and I have none. So in this case, I'm going to have to add 4 0 pairs. There's one positive number. Here's 2 positive numbers. There's 3 positive numbers. And I'm going to add in one more 0 pair. There's now 4 positive numbers. So now I can actually perform this operation of taking away 4 positives because I have them right here. So we're going to take those away. 1, 2, 3, 4. And you're going to count what's left. I have 1, 2, 3, 4, 5 negatives. So your answer to -1 minus 4 is a -5. Number 3. This time we're going to start with 2 positive numbers, so that would be 2 white counters. And we have to take away 7 positive counters. I only have 2 to take away, but I need 7 total, so that means I'm 5 counters short. So that right there tells you how many 0 pairs you need to add. If I'm short 5 positive counters, I need to add 5 0 pairs here. So here we go. Now that gives me 3 positive numbers, 4 positive numbers, 5 positive numbers, 6 positive numbers, and finally I have 7 positive numbers that I can take away. So I had to add 1, 2, 3, 4, 5 0 pairs. Now I can take away the 7 positive numbers. So here's 1, 2, 3, 4, 5, 6, 7. Count what's left. I've got 1, 2, 3, 4, 5 negative numbers. So the value of 2 minus 7 is -5. Bear in mind that I'm using small numbers so that you can understand how to use the counters and model it. If these were bigger numbers like 543 minus a -276, you need to be able to understand the rules, which we'll get to in a minute. Let's look at number 4. So this time we start with 3 positive counters to represent that positive 3. And then we have to take away 2 negative counters. Well, I have 3 positive counters. I have to take away 2 negative counters. I have none. I don't have any negative counters. So if I want to get 2 negative counters here so that I can take them away, I'm going to have to add 2 0 pairs to get those 2 negative counters. So here's 1 0 pair, giving me 1 negative counter. And here's a second 0 pair, giving me my second negative counter. So then this time, I can take away the 2 negatives. So there's your 2 negatives, and count what's left over. 1, 2, 3, 4, 5 positive numbers. So our answer to 3 minus a -2 is a +5. This problem is most commonly answered in error by saying that the answer is 1. And so if you use counters, you can clearly see that nope, the answer is not 1. It's actually a +5. All right, look at number 5. So we start with 1 negative counter. And the problem says to take away 3 negative counters. Well, I have 1 negative counter. I need to be able to take away 3 of them. So I'm 2 negative counters short. So I have to add 2 0 pairs. So here's 1, and here's 2. Now I have enough negative counters to take away 1, 2, 3 of them. Count what's left over. 1, 2. And so my answer is 2 positive. So +2. Last one with counters. So this time we're going to start off with 4 negative counters. And the problem asks you to take away 5 negative counters. Well, I already have 4. I almost have enough. I'm short 1 negative counter. So that means I'm going to have to add 1 zero pair and only 1 zero pair. So now I have 5 negative counters that I can take away. 1, 2, 3, 4, and 5. And then count what you have left. We only have 1 positive left, so the answer is positive 1. So then let's look at the subtraction rule. So here's your subtraction rule. And the subtraction rule, essentially in algebra, we no longer subtract in algebra. We change everything to addition. So there's no more subtraction problems. We're going to change any subtraction statement into an addition statement. And the general rule of thumb is to change subtraction to addition, you're going to add the opposite. And then we're going to follow the addition rules. So we're going to change everything to an addition problem and then just follow the addition rules that we went over yesterday. So what does adding the opposite mean? So a lot of you in middle school learned the mantra, keep, change, change. That's an A. And what this means is you're going to, so if you're looking at a problem like this, you're going to keep the first number exactly as it is. You never ever change the number that's in front of the subtraction sign. You keep it exactly as it is. Then change means you're going to change subtraction into addition. And then the second change means you're going to change the sign of only the number that follows the subtraction. So you're going to keep, change, change. So I would like to see you not do this in your head. We're not going to use the counters, but you're going to actually show the adding of the opposite by performing this keep, change, change. So use a different colored pen or pencil than what you're using to do the problem with. And then we're going to go ahead and go through this. We're going to keep, and then we're going to change this subtraction to addition. You can actually show it. And then the 5 here was originally a positive 5. Now we have to change it to a negative 5. So really what we have is 3 plus a negative 5. So remember your addition rules, we have different signs subtract. So we're going to subtract and do 5 minus 3, which is 2, and keep the sign of the larger. Well, there are more negatives than there are positives, so our sign is negative 2. So our answer to 3 minus 5 is negative 2. And notice that these 6 problems here are identical to the 6 problems that we just did with counters, but we're just going to run through the keep, change, change rule. So number 2, we're going to keep, and then we're going to change this to addition. We're going to change the positive 4 to a negative 4. So now we have a negative 1 plus a negative 4. So same signs add and keep the sign. So we're going to add 1 and 4. That gives us 5. And we're going to keep the sign, which is negative. Number 3. So again, we're going to keep 2 exactly as it is, but we're going to change. So plus, minus. So this time we have a positive 2 plus a negative 7. Different signs subtract. So 7 minus 2 is 5. And keep the sign of the larger. There are more negatives than there are positives, so our answer is negative 5. So all 3 of these problems we were subtracting a positive. So in 4, 5, and 6 we're going to be subtracting a negative. So look at how that's slightly different. So we're still going to keep change, but we're going to keep the first, and then we're going to change subtraction to addition and change the sign of the negative to a positive. So we end up with a very simple problem, 3 plus a positive 2. So same signs, add and keep the sign. So we're going to add 3 and 2, which is 5. This sign is positive, so we're going to keep it as positive 5. Next one, we're going to keep the negative 1, and then we're going to change. So we end up with a negative 1 plus a positive 3. Different signs subtract. So 3 minus 1 is 2, and keep the sign of the larger. There are more positive 3's than there are negatives, so we're going to keep the sign as positive 2. Notice how all of these are turning out to be the identical answers to what we had in the 6 problems above. So very last problem, number 6. So we're going to keep the -4 and we're going to change. So change subtraction to addition and change the -5 to a +5. So we've got a -4 plus a +5. Different signs subtract and keep the sign of the larger. So we've got 5 minus 4 is 1. And then there are more positives than negatives. So our answer is +1.